Hi, I'm Dr. Mark Trexler, and welcome to this Climate Web Topical Dashboard exploration. What we're going to explore in this video is a very interesting question that's really come to the fore in the last couple of years, and it's the interface between the oil and gas industry and the potential phase out of the oil and gas industry for climate change reasons, and the potential for that to accelerate the geothermal industry. So let me start with just a quick look at geothermal generally. Geothermal is not a new technology. We've been producing electricity from geothermal around the world for many years, albeit at very small scale, as you can see in this graph. The question is, what is the potential future of geothermal? And so this is from a big study looking at energy out to 2050. And if you take a look, you can see on the right-hand side, you can see geothermal, this little pink color. But if you look in the diagram, it's actually very hard to find that pink bar, which is above nuclear here. You can see that the expectations for geothermal out to 2050 are very small. And let's even take a look at this in the context of just renewable energy from the same report. Here you have wind going up, solar going up, hydro going up, everything going up, except geothermal basically is level out to 2050. Very little expectations for geothermal going out to 2050. Now, it is true that the hotter the resource, not surprisingly, the better the resource from a power generation standpoint. Just for example, if you have 400-degree steam and water centigrade degrees, you can produce 100 megawatts of power basically with one injection and a couple of production wells. When you get down to 200 centigrade, you still produce power, and this will become important as we'll see in a map in just a minute. You can still produce power, but the footprint of the operation is quite a bit bigger, 18 injection wells, 24 production. So obviously the high quality steam and energy that geothermal has tended to rely on to date is preferable for electricity production, but it's by no means the only way to get electricity out of geothermal. There is a lot of work going on in the high-powered space, and some of the studies actually suggest that high-temperature geothermal could be the most cost-effective energy source available to us. In this diagram, $46 per megawatt hour compared to $56 for onshore wind, $99 for natural gas combined cycle. You can see here that's not where geothermal is today, 80 to 120. This is one very interesting story from earlier this year, a technology that is looking to go 3 to 20 kilometers deep with a new way of melting rock, basically, to get to the heat underneath. And here's just a little more information on this story on KZ Energy. They are going in and going potentially 12 miles to get to 700-degree Fahrenheit rock. And they're shooting for 1 to 3 cents per kilowatt hour, which obviously would be very cost effective against other fuels and even against other renewables. Coming back to the geothermal resource, we've talked about the fact that the high temperature resource is better for conventional geothermal. You can see here that the high temperature resource tends to be in the western US, but you can look across the entire US at 10 kilometers, about 6 miles down. Everything is above 150 degrees centigrade, and there's a lot you can do with 150 degrees cent heat. And so that really applies across the entire US, and we'll get to what you can do with that heat in just a second. But one study suggests that if you go down an average of 4 miles in terms of drilling, get to that 150 degrees centigrade, you could arguably supply the entire US electricity demand, and you could supply the entire US need for process heat. And that's actually a very interesting thing about geothermal as compared to wind and solar, because we use heat in different ways. And high temperature heat is great for power generation, hydrogen production, but you can still produce power at lower temperature at 120, 150 degrees centigrade. But then you also get into all of these other ways that we use heat directly. And this is actually something that wind and solar don't do very well. They produce electricity. They don't produce heat very well. And so geothermal also has the option of directly producing the heat that can be used in all kinds of processes. Now, people recognize that with the right support, geothermal could probably expand pretty rapidly. Here is a business as usual trajectory. Here is a with some policy improvements trajectory. And here is with technology improvements trajectory. And the thing to remember here is that over the last 10, 20 years, solar and wind have really been advancing technologically and coming down in price. That hasn't been the case for renewables to date. And if we prioritized geothermal to that end, one could make a lot of progress in terms of how much geothermal we're able to exploit. Now, something interesting here, and this gets back into the overlap between geothermal and oil and gas. Geothermal is all over the country. We already know that. Oil and gas isn't all over the country, but as you can see, this is active oil and gas wells, of which there are more than 1 million in the United States. So some of that on the West Coast, much more here in the Midwest and South, and then to some extent into the Northeast. The point is there are 1 million wells that have already been drilled. There are 1 million abandoned wells that have already been drilled that could be leveraged potentially, as well as the drilling expertise of the industry, to really reduce the costs of going after those geothermal resources. And in fact, just very recently, a story came out about in Colorado. This company has actually used an oil and gas to produce geothermal energy is on demonstration basis. So we're starting to see the potential for this overlap playing out. A lot of people think that the environment for moving forward with geothermal is finally falling into place, literally just in the last year or two. There are more and more startups coming into this space. Finally, there is investor interest in the context of low carbon transition. Finally, there are more ambitious renewable energy goals that can drive the technology, the development. And so we may be entering a sweet spot for geothermal going forward. And as I mentioned, relying on oil and gas infrastructure could significantly reduce costs. By one estimate, if you can substitute geothermal for a well, as opposed to having to pay the costs of shutting down and abandoning that well, you can potentially reduce the cost of the geothermal from 4 to 2 cents based on the co-benefit of not having to spend the money on shutting down that well otherwise. So there is this huge potential incentive to take advantage of this infrastructure to accelerate the fall in the price of geothermal. I've been focused on electricity production. This is an interesting headline talking about how this new housing development is entirely heated and cooled with geothermal, resulting in extremely low energy costs. So this is just one example of being able to use that direct heat of geothermal without having to go through the electricity cycle. And this could be done all over the country in many different respects. So what are some key points? Some key points is there is a large resource for high temperature geothermal in the United States, and those technologies are advancing. It could be the most cost-effective energy resource, period, much less renewable. Massive lower temperature geothermal resource in the United States, covering the entire US. Theoretically, it could supply all the electricity, all the process heat, could economically leverage the existing oil and gas infrastructure that's being demonstrated now. It could offer oil and gas sector stranded assets off-ramp and reduce power costs. There are some real synergies there in terms of being able to take advantage of the expertise and the jobs in that sector to transition them into renewable energy generation. Another interesting point compared specifically to wind and solar is that the above ground footprint of geothermal can be very low. In some cases, for all practical purposes, zero, because everything's happening far underground and there is very little happening above ground. The other fact, of course, is that geothermal can produce baseload power, unlike solar and wind. It's power that can be turned on and off. And so in many respects, it's the ideal resource. The one question people have, and this goes back to the idea of fracking for oil and gas, is what about the possibility of seismic impacts? Because we are putting water into the ground with the geothermal. The key point here that the geothermal folks emphasize is that number one, you're not dealing with the chemicals that are involved in natural gas fracking. And number two, you're not using water at anything like the pressure that is being used for natural gas fracking. So the potential for seismic impacts should be much lower with geothermal than it is for seismic. Now I'm jumping it back to the actual dashboard that I have been extracting from. Everything that I've been talking from is available here in the dashboard, but there's also quite a bit more. There are a number of great videos on this topic that you can take advantage of, but they're linked to here. You can actually watch them right from the dashboard. All of the different news stories and more are here. Key graphics are here. Many of the key companies in this space you can take a look at and explore through the dashboard. So it's a great way of being able to dig more deeply into this particular topic, and is one of hundreds of topics you can explore in the climate web. Thanks.